Okay. Our next speaker is Dan Olds from OrionX, and he'll be talking on the HPC High Performance Interconnects landscape.
And landscaping. Landscaping as well, yes. Turn this on.
And you will use this one or this one?
I can use that one. Hello. Oh, this works. Okay.
See? Then I switch it,
Okay.
I switch it off then.
Okay then. Okay, I am Dan Olds. We are going to talk about high performance interconnects, the landscape, assessments, some rankings. Overall, this is a very important topic, and it's going to become even more important in order to get performance out of supercomputers. One of the things I wanted to point out here in a recent survey we did, customers are spending more money and paying more attention to interconnects. Of course, without an HPI, high performance interconnect, you really don't have a cluster. You just have a bunch of machines. So these things are critically important to getting performance out of the systems, and customers are seeing that. Also, one historic fact, I went back and looked at high performance interconnects over the years and found that they've been increasing in performance at about a 30% rate, which is a big number. Not quite Moore's Law, but pretty high. So the segment we're talking about, I'm not sure how well you can see that in the back, we set the HPI line kind of there in our graph. It's multi-rack, multi-system, of course, and it's typically 100 gigabits per second on up. And that's where you're seeing InfiniBand, you're seeing specialized proprietary interconnects, you're also seeing Intel's new entrant OPA, OmniPath architecture. Driving on, and MPI is the protocol that we see there. So what are the three types of HPI? This is all pretty basic stuff for all of you. Ethernet, a lot of Ethernet out there still, a lot of Ethernet still in the top 500. Providers are Cisco, HP, Juniper, anybody else who can throw together a switch will offer a high performance Ethernet interconnect. It's tried and true. It's also the easiest to adopt, as we'll see, but performance is a problem. Not bandwidth, but latency. You measure latency in Ethernet in MS rather than nanoseconds. Proprietary interconnects, primarily sold by Cray, SGI, IBM, and others. Good way to go, but you have to purchase a system in order to get it. Now, the newest proprietary interconnect is Intel's OPA, and you don't have to purchase a system to get it. Mellanox, InfiniBand, they're kind of synonymous as a de facto market leader. Right now, highest performance based on published numbers. So let's talk about some of the key differences. Market maturity, position in the market. Ethernet's been around longer than anybody else, but has been surpassed in performance, as we just talked about. A lot of installations, but it's lost share at the high end. Take a look at the top 50 interconnects. There isn't any Ethernet anymore. It's kind of a surprise. Just a couple of years ago, there was. Top 100, just a handful of Ethernet HPI out there right now. And again, the problem is the performance. Taking a look at Intel OmniPath, it's brand new, starting to ship now. Still in its infancy. It does have pretty good numbers, at least from what they're saying. They have a handful of customers and some very big names among them. But some of the claims we're going to take a look at and test a little bit. But as you can see in the top 100, just a few systems with Intel OPA right now. InfiniBand has been around since early 2000s, late 1990s. Lots of customers, lots of nodes. It's now making up almost half of the top 500 list, primarily in the upper part of it. And if you break down where they're at, you see that InfiniBand, as a single HPI, has a greater market share, at least on the top 50 systems, than the Cray Aries, Gemini, and the custom proprietary, which would be Tofu, IBM's Blue Gene, etc. Keep going back and forth. I should carry the laptop with me or drag that table over. So yeah, it's distracting, but that's okay. This is going to be the battleground that we're going to talk about for years to come. Onload versus offload. This is going to be made, it already is being made into a big deal. It's going to be made into a bigger deal because this is the main differentiator between InfiniBand and Intel's OPA. Oh, it's okay. No, it's fine. Thank you, though. I appreciate you looking and digging that up. I don't have that many more slides anyway. Onload. This is where the main CPU is handling all of the network protocols, the processing, MPI collectives, etc. It's kind of like the old PC servers and Unix systems, where the main CPU dealt with all the interrupts, the communications interrupts. Offload is where the switches and the HCAs handle all of that load. And that's akin to, first of all, it's InfiniBand, but it's akin to mainframes, where mainframes have an assist processor that handles all the communications, so they're not interrupting the CPU with that. Let's get into some details on onload and offload. Here's the stuff, the list that I put together of what happens in a network transport, a network transaction. You've got the link layer, the network layer, the transport layer, then you have MPI operations as well. Scatter, gather, gather, scatter, all that kind of stuff, broadcast. In an offload, all these operations are handled by the networking hardware, the HBA, the HCA, the switches. That's with offload. Conversely, or oppositely, same tasks, but in an onload, the CPU and the main memory are handling all of the tasks. That's your difference. That's your onload versus offload. So comparing and contrasting a little bit, it's not a big deal, I don't think, in a small cluster. By the way, this is the head node. Most head nodes don't look like a real head, but if you have one that looks like a real head, send me a picture because I'd like to see it. Boy, that went real well. So,
That's good, Dan.
well, thank you for laughing then. Like you didn't. Yeah. So what's happening is typically the job is going to be submitted through the head node. It's going to go out through the switch. Tasks will go out and be assigned to the various nodes. In a small cluster like this, not a big deal. But the story changes when you get to a big cluster. And again, the same process, right? We've got a big cluster here, 18 nodes per switch, out to 72 switches, all being aggregated by two 648 port big switches, core switches. But we still have that head node, and that head node is still dispatching jobs to all of those nodes. And it's receiving data back from all of those nodes. And what will happen is when you get into a big cluster system, your head node is going to get just overrun, punished with that workload. And I think that that's going to be a problem when onload versus offload, where offload is starting to look a lot better. Particularly when you're talking about scatter, gather type collective things. A couple of other things, as I just said, as node count increases, I believe performance on onload will drop. It's because of the higher node count means more messaging, more pressure on the head node, and on the head node CPUs. Node counts are also increasing significantly over the years. I went back on the top 500, top 100 of the top 500, and took a look at where node counts are going. And we're up by 50% over the last 6 years. The thing I like about the offload architectures, they have dedicated ASICs that are faster than general purpose CPUs when you're talking about these communication things. They're doing all of it in hardware. And hardware is where you're going to get the most performance. The other point is an MPI is not all that parallel and not all that parallelizable. So what's happening is with onload, the speed of your MPI is going to be highly dependent on the single core speed of the CPUs that are processing it. And when you start looking out at like PHYs, for instance, Knight's Landings, those are pretty slow core speed, pretty slow frequency. That won't have any bearing on an offload. The FUD war. FUD, fear, uncertainty, doubt. It's being fought. It's raging. It's going to get a lot worse. This is a slide from Intel talking about how the budgets for clusters are breaking down. And they're positing here that With their OPA, the total budget for HPI in a cluster will be around 24, 25%, which is about what it is today. But then they're also saying that InfiniBand is going to be more expensive, EDR. I don't really know why or how they can say that, because as I've observed in the industry over the years, typically the price points stay the same, and you get more performance for that price. For instance, a full-up laptop, top end is about $3,000, $3,500. It was 5 years ago, and it was 5 years before that. Server, two-way server. The node price points stay about the same, but you're getting more performance for it. And I think from everything I'm seeing is that we're going to see the same proportions on both sides. I don't think there's going to be a cost advantage. Yes?
I think the reason for Intel stating this is that for OPA, the switch radix is larger than for InfiniBand. So you have 48-port switches compared to 36, means that you need less switches for OPA.
Depends on what size cluster you're putting up, though, right? If you can cherry pick and take some sizes and make that work, but it really depends on how big the overall cluster is going to be. And I think street prices in deals come down to being roughly equivalent for technology. And again, we're talking the street price, not list price. List price is a different story. Addison.
Dan, can you tell me what the word is I can't quite make out? In the orange bar, 750 watt to 948 watt.
750, what they're positing is that you could have enough money for 750 servers.
Servers. I
Yes,
couldn't read that
versus
word.
948 with the happy Intel pricing versus the evil EDR pricing. Yeah, colors aren't great.
And that's a pure cost perspective?
That's, yeah.
That's not
list-
performance per TCO
No.
dollar?
No, that's pure cost. And it's hard to figure out exactly what they're saying. Their footnotes don't go into an awful lot of detail on exactly what they're comparing on that one. I do have some more detailed footnotes on these others. They're also talking about MPI bandwidth being higher with OPA, latency being lower, and the message rate being 27% higher with OPA. These are all things that appeared in a story, and all these charts came from Intel. So what do these images have in common? It's all about the fine print, as it turns out. When you go in and look at the disclosures, you see some things that are really interesting. For instance, prefetch is disabled on the Mellanox side. They're also using something called dapl with Intel MPI. What dapl does is it has the effect of turning off the offloading, which if you're comparing to an InfiniBand that's all about offloading, suddenly you've taken away their advantage. You've taken away the entire reason for it existing. It's like this bullet using Intel MPI and software that doesn't allow for offloads. That's a problem. That doesn't make those, that makes those results that we had in the slide earlier quite suspect. And this is the one that really kind of bugs me. Well, pisses me off, I guess, would be a better way to put it. It's because if you take a look here, and I'm not sure how clearly you can see this, but it shows at 28 core pairs, I'm not exactly sure what a core pair is, but at 28 core pairs, the EDR box is using up every CPU cycle there is. So the CPUs are 100% utilized right here at this point. Intel at 28 says they're only using 65% of the CPUs, which is a hell of a lot of CPU to be using for communications. That's CPU that's not being used to actually run the applications, just to run the network load. But if this is true, then that half of the systems that are on the top 500, which are way over 28 core pairs, are essentially useless. They're just running communications. And we know that's not true. So that's the problem I really have with this benchmark, and it's that dapl that we saw on the slide before that is disabling the offload for the EDR box. Any questions on this? Yes?
Well, not a question, but a remark. it's highly dependent on the NPI library and the way that it does do its part.
Absolutely it is.
Because you are doing an NPI benchmark,
Yeah,
not a lower level
exactly.
HPI benchmark.
And what Intel did is they used Intel NPI. And as they say on, you go one slide up, this is your key phrase right here. Software and workloads used in performance tests may have been optimized for performance only on Intel microprocessors. They used Intel MPI on that. They did not use Open MPI. And as we can see, that makes a pretty big difference. So what they did is they tested an offload processor but used a mechanism that didn't allow it to offload at all. So of course it's going to look horrible. That's the thing that bugs me. I hate seeing this stuff. So FUD aside, here are the numbers as best I can figure them out. Both of them have 100 gigabits per second I/O, or excuse me, 100 gigabits per second bandwidth. Latency, 93, 85 nanoseconds, 0.85 nanoseconds. That's pretty good. They're both pretty good on that. Message rate, this has been kind of interesting because about 18 months ago, Intel came out and said that they were going to have 160 million messages per second on OPA, and that's gradually come down to where the latest public thing I can see is 89 million messages per second with OPA, and Mellanox is holding it to 150 million per second. Roadmaps, I can't find a public, solid Intel OPA roadmap. The Ethernet roadmap shows 200 gigabits per second in the 2018-2019 timeframe. The InfiniBand roadmap is pretty solid, and these numbers have been hit over the years. We're looking to have 200 gigabits per second next year, and I would say probably the year after next, looking at 400. So that's the futures. What we did at Orion is we went through and rated Mellanox, Ethernet vendors, and Intel on their HPI. And what we looked at in the market, presence. Are they present in the market? How well are they present in the market? Trends. How well are they following or leading market trends? And then kind of average those two scores here. Customer readiness, what that means is how easy is it for the customer to adopt that particular technology? And does it meet the customer needs? And this is the average. Product, capabilities, roadmap, and an average. And as you can see, InfiniBand as the proxy for, or Mellanox as the proxy for InfiniBand does pretty well, particularly in the market and in the product side. With the roadmap, with the capabilities today, the market presence and the market trends, Ethernet wins when it comes to adoption, to readiness. Easiest to adopt Ethernet, everybody already has it. And the way we are showing this is through what we're calling our Orion constellation chart. And this is our way of showing, comparing the vendors on these various axes of needs, the customer side, the product side, the market side. As you can see, readiness and presence, needs and capabilities. I also threw up the little cheat chart here so you can see what we're seeing, how we rated these. Any questions? I've been going awfully fast. Comments? Concerns? So I think that that's it. Questions? Comments? Yes?
Do you hear anything about Intel considering the offload approach to their new?
That's interesting. I heard something about that, but that's going to, if it's going to happen, that'll happen when they start to bring the Aries technology into it that they purchased from Cray, because I believe that that's offload technology. But as they are now, according to them, they've found the right way to do it, and they're going to push forward with that regardless. But keep an eye on it. It could change. Anything else?
Yeah.
Yeah.
Do you try to reproduce the benchmarks that you showed before with offload activated so as to get some comparison?
There are some comparisons out there, not the exact same benchmarks that I've seen. Mellanox has run some stuff, and they have it up. I didn't myself, because, well, one major reason why I didn't do it, I'm too stupid, but I would have otherwise, and if I had a bunch of equipment. But that's if I were Mellanox, I would reproduce exactly those and do it. Other questions, comments? Well, thank you very much. Oh, yeah.
You had a slide that said that there wasn't a dependency on OPA as far as the system. Is it tied to the system?
Oh, yes.
And then how does that reflected with the dash F coming online, where they're integrating it on a package?
That's going to be a bit more interesting, but it's not like you have to buy. What I meant by that is if you wanted to get IBM's Blue Gene Interconnect, you had to buy a Blue Gene. If you want to get Cray, Gemini, or Aries, you got to buy a Cray. But Intel's not really going down that road, right? If you want to get the SGI Interconnect, you got to buy their box. Now, you're going to be buying an Intel box anyway, most likely, but you don't have to. You don't have to buy it as one package. Anything else? Good. I think I got us back on time.
Good, thank you.
Thank you. I appreciate it.